morning, students. In the last class, in computer system architecture, we completed till the structure of instruction. Okay, what is instruction format? How ALU executes an instruction? That is, the execution portion is carried out in what way? What all it needs? How the operands are fetched? And the type of operand is specified by various addressing modes. So in the last class we completed entire almost every addressing mode, isn't it? There are 7 to 8 addressing modes and we discussed each and every one of them. We discussed about the relative PC addressing modes, the indexed and base indexed addressing modes. Now we will continue our discussion to instruction execution. Okay, how and what are the steps involving in total complete execution of an instruction. Okay, earlier we just discussed about how CPU, or we can say the part of CPU called arithmetic logical operation, extracts an instruction. But here we will continue our discussion from the very beginning, that how instructions are taken, how operands are fetched, then what all process happen and entire execution is completed in what way. Okay, so in instruction execution, generally it is broadly classified into 4 stages. How many stages? Usually 4 stages. Okay, first stage is instruction fetch. Second step is operand fetch. Third step is execution. Fourth step is write back. Okay, I'll write the full forms so that you are not confused. First of all, we need to fetch the instruction. That is instruction fetch. Okay, then we have to fetch the operand. The operand fetching is also called instruction decode. We can say instruction decode. Okay, or operand fetch, whatever. Next is execution, where the arithmetic or exact execution of the instruction takes place. After that, we have write back. What does write back says? Write back means we have to put the result at the desired position. Okay, we may have to write the result in memory, or we may have to write the result in registers, some registers. Okay, it depends upon what the instruction is asking us to do. Okay, so this is instruction decode, this is execution, this is write back. So these are the 4 broadly categorized steps in executing an entire instructions. Okay, so before moving forward, we will discuss a few things so that we can relate how these all are being performed with respect to an example instruction. Okay, so first of all, we need to understand that an computer system, in the computer system, the main, or we can say the heart of the computer system is CPU, Central Processing Unit. Okay, because computer is essentially a device which processes something. Okay, so without the processing unit, computer has no significance. So the CPU in general consists of a part called ALU and CU. This you have studied already. Okay, now the control unit guides the ALU, or we can say the entire processing unit, about which circuitry to activate at which time. Okay, if addition is performed, the control unit gives signals to ALU that ALU, you have to do your duty now. Suppose there are other circuits. Okay, then control unit has to activate those circuits when their requirement is needed. Okay, So similarly, control units is, we can say, the brain. Okay, it tells you. Okay, likewise, our brain also tells us, no, gives us signal that we have to lift our hand or we have to do something in self defense when we are in danger. These signals are given to us by brain. We know how to walk. Okay, how we know how to walk? That we have to move our leg while walking, because the brains gives us such signals. Okay, similarly, control unit gives signal to activate all other components whenever their work is necessary. Okay, now ALU, we will majorly focus on ALU because ALU carries out the instruction mostly. So ALU has a component called memory register. So in general, a computer system has 32 to 64 registers. So these are limited. We cannot have unlimited registers. Okay. So it may have 32 or 64 registers. It depends upon architecture to architecture. But ALU has limited number of registers. Okay. So now coming to our instruction execution. Suppose we are given an instruction called R1, R2, add. So what it does essentially, this instruction means we have to add R1 plus R2 and so store the result back in R1. Okay, so this instruction means this is the task we have to perform. We have to take the operand in R1, we have to take the operand in R2, and we have to add and store the result back in R1. Okay, so this is performed in 4 stages, as I said. What are the stages? Instruction fetch, instruction decode, instruction execution, then we have write back. We have to store the result at the desired place. Where we have to store the result here? We have to take the addition and we have to store it in R1. This is the write back process. Okay. So we will see how it happens. Okay. Taking this example, we will understand how the 4 stages work. First of all, we have instruction fetch. So what happens in instruction fetch? Okay. First, in instruction fetch, this entire instruction, that is opcode, then we have operand, no, OP1, OPR2. Okay. Suppose this is an instruction. We already studied instruction format. Okay. This entire instruction, the opcode is add here. We may have various opcode, isn't it? We may have subtraction, we may have multiplication, we may have division, we may have mod, we may have increment, we may have decrement, various operands we may have. I am taking an example where opcode is add. Okay. So here this entire instruction is moved to instruction register. This entire instruction is moved to instruction register in case of instruction fetch. So what happens in instruction fetch? Instruction is moved to IR, instruction register. Okay. So what is the second step? Second step is instruction decode. In instruction decode, we have to see what addressing mode it is. Okay. Suppose it is register addressing mode, as it is evident that the operand is present in registers. Okay. So in instruction decode, the what we can say, the operands are fetched from the registers. Okay. Operands are fetched from source as per addressing mode. as per the given addressing mode, the operands are fetched from the source. Here the addressing mode is register addressing mode. So in this case, we have to fetch the operands from R2 and from R1. Okay. So after instruction decode, we have execution EX. In EX, what happened? We have to perform the addition. So what happens here? ALU performs addition. Okay, clear and simple. After that, write back happens. In write back, what happens? The result is stored in desired location. So here, the desired location may be memory or register or whatever specified. In this case, we have to store the result where? In R1, isn't it? This is the case. The addition is stored in R1. So here the result, that is the addition of the two operands, will be stored in the register R1. Okay. I hope it is clear to you. So we have taken an example here and I am showing you the entire execution process stage by stage. So we have usually 4 stages in case of instruction execution. First one is instruction fetch, second is instruction decode, third is execution, fourth is write back. Okay, so both these stages constitutes of fetch cycle. Okay, these two stages combined is called fetch cycle, and these two stages combined is called execution cycle. Okay, this is important to remember for you. Okay, the entire execution consists of two major cycles. First one is fetch cycle, which constitutes of instruction fetching and instruction decoding. Okay, and the second cycle is called execution cycle, in which we perform the execution of operation. After that, we have to store the result at the desired places. Okay, I hope it is clear to you. We will continue our discussion in the next class. Meanwhile, if you people have any doubt, you can comment in the comment section, or you can directly message me or email me in my email ID. Okay, thank you.